All right. Continuing in our synthesis, we're going to start putting together finding characteristics of polynomials and the rational roots theorem. Yeah. All right. So first, we're given this polynomial. It's in standard form, and we know that because there are no parentheses, there's no multiplication, it's just a string of addition, subtraction. Which means when we're finding the degree of the polynomial, we need our highest exponent. And that means that we have a degree of 4. The number of x-intercepts is the same as the degree, which means that we have 4 x-intercepts, zeros, roots, solutions, all the same thing. Max number of turning points is always n minus 1. So when we're going from degree to turning points, we subtract 1. When we're going from turning points to degree, we add. But here we're going to have 4 minus 1, which gets us 3 maximum turning points. Our end behavior of the polynomial is what's happening on the ends or on the arms. And we need to pay attention to our leading coefficient and our degree. Our degree is 4, which is even, and because it's even, we know that the arms are the same. And since our leading coefficient is 1, which is positive, we know that the right side rises. If our right side rises, and our arms have to be the same, that means to the left we also rise. So our end behavior is that we rise to left and right. If it were odd, our arms would go in opposite directions, but here they're even, so they are the same. When we're looking at the possible zeros for the rational zeros theorem, that's where we want the P over Q, where P is our factors of our constant term, which is 10, and Q is our factors of our leading coefficient, which was 1. Factors of 10, we know 1 and 10 multiply to be 10. Next number up from 1 is 2. 10 divided by 2 gets me 5. Next number up from 2 is 3, but 10 divided by 3 gets us a decimal. And next number up from 3 is 4. 10 divided by 4 gets us a decimal, so don't include it. And then we're up to 5. So we're done. Factors of 1 are just 1. Now that we have both our P and our Q, we can do our plus or minus P over Q. And I'm going to do the plus or minus outside of the bracket because then I don't have to write positive 1, negative 1, positive 2, negative 2. Because we're going to take all these factors of 10 and divide it by factors of 1. 1 divided by 1 is 1. 2 divided by 1 is 2. 5 divided by 1 is 5. And 10 divided by 1 is 10. And if you wanted to write these out individually, you could for the positive 1, negative 1, positive 2, negative 2. But it's not necessary if you put the plus or minus with the brackets. We're asked to find all zeros of f of x, which means we're going to be using some synthetic division, maybe some factor by grouping, quadratic formula, who knows. But if we graph it, and I've already graphed it, notice that we do have 3 turning points. There's one at negative 1, another one at x equal to 1.29, and then a third one at x equal to 2.71. So that took care of our turning points, which is pretty cool. Notice that Our only x-intercept zero root solution that's real is -1. That's the only place where we cross or touch the x-axis. So when we're setting up our synthetic division, we're going to put -1 in the loser corner and then use our coefficients from our polynomial. We have 1, -4, -1, +14, and then 10. Remember, with synthetic division, you give yourself some space. The first one always comes down. -1 times 1 gets us -1. Add vertically, we get -5. -1 times -5 gets us +5. Add vertically, we get 4. -1 times 4 is -4. Add vertically, we get 10. -1 times 10 is -10, which gets us a 0. And we just found that x equal to -1 is a 0. And we also found that x plus 1 is a factor. Remember that we started with an x to the 4th, but when we drop down below the line, we come down to an x cubed, which means that our remainder polynomial is going to be 1x cubed minus 5x squared plus 4x plus 10. We're going to use that remainder polynomial to do synthetic division again. And you may be wondering to yourself, how am I going to do synthetic division again if the graph only touches the x-axis at -1? But if you notice, it touches and turns at x equal -1, which means it has an even multiplicity and it has got to show up at least 2 times. So that -1 is going back into, excuse me, our loser corner, and we're going to take these new numbers, new coefficients, from our remainder polynomial. So 1, -5, 4, and 10. Again, giving ourselves some room. First one always comes down. -1 times 1 gets us -1. Add vertically, we get -6. -1 times -6 gets us a +6. Add vertically, we get 10. -1 times 10 gets us -10, which gets us a 0. We just found again that x equal -1 is a 0. And x plus 1 is a factor. We also found out another remainder polynomial. We had started with an x cubed and we dropped to an x squared. So our new remainder polynomial is going to be x squared, or 1x squared, minus 6x plus 10. We're going to use that to solve for our remaining zeros. Notice that we do not cross or touch the x-axis anywhere other than -1, which means our remaining 2 zeros are going to be imaginary. And because they are imaginary, we are going to use the quadratic formula. So again, we're going to use quadratic formula to find the zeros or to solve our new remainder polynomial. x squared minus 6x plus 10. Here we have a is 1, b is negative 6, and c is 10. We're going to plug into the quadratic formula. So x is equal to the opposite of b, which is negative 6, plus or minus the square root of b squared, so negative 6 squared, minus 4 times a, which is 1, times c, which is 10, all over 2 times a, which is 1. Let's go ahead and start simplifying. Negative 6 gets us positive 6, plus or minus. And when you put the entire radicand into your calculator, make sure that you put the parentheses around the negative 6. So when you take negative 6 squared minus 4 times 1 times 10, you should get negative 4, because you have 36 minus 40. All over 2 times 1 gets us 2. Because we have a negative under the square root, we get to take out an I. So we have 6 plus or minus I square root 4 all over 2. Square root of 4 is 2. So 6 plus or minus 2i all over 2. You can't combine the 6 and the 2i because they are not like terms, but we can simplify these. 6 divided by 2 gets us a positive 3, plus or minus 2i divided by 2 gets us I. And we just found that x equal to 3 plus I is a 0, as is x equal to 3 minus I. Breaking up the plus and minus. If you're wondering about the factors, we would subtract both the 3 and the I over to the left-hand side. So we would have 3 minus. So we would have x minus 3 minus I as our first factor. And then x minus 3 plus I as our second factor with the imaginary numbers. We're asked for the real zeros, determine their multiplicities. With x equal to -1, we found it twice, which means its multiplicity is 2, which makes sense because it was touching and turning on the graph. For x equal to 3 plus I and x equal to 3 minus I, these guys are not real, so we don't need to worry about their multiplicities because they're not touching the x-axis. They're not distributing a behavior of the graph at the root. But at x equal to -1, since his multiplicity is even, he is going to have the graph touch and turn, or you could say bounce, at x equal to -1. Last part, we need our function in factored form, and our function was f of x. The very first factor we found was x plus 1. And then we found x plus 1 again. From our quadratic formula, we found x minus 3 minus I and x minus 3 plus I. I'm going to make this look just slightly nicer by putting the x plus 1 to the second power. So we have x plus 1 squared times our x minus 3 minus I factor times our x minus 3 plus I factor. And here we are in factored form because we have the parentheses and they are all multiplied together.